quadratic equations using the quadratic formula. The quadratic formula is a result of a mathematician, some many years ago, taking a look at the process of completing the square, theoretically speaking, and following that process without numerals in front of the x squared term, the x term, and the constant. So what that person did is they took the coefficient of the x squared term and divided both sides of the equation by what I'll call a. And then they moved the constant over the right-hand side, and then they took the coefficient of the x term, which was by then b divided by a, letters, and took half of it and squared it and added it to both sides of the equation, etc. The proof that I'm speaking of is in the very first part of this section called the quadratic formula. I'm not going to share that with you. I'm just going to show you its use. It is probably my favorite way to solve a quadratic equation. It's very simple. Hard to make a mistake if you're careful. Here's a problem that I'd like to look at. 2x squared plus 5x minus 12 equals 0. And what I need you to understand, excuse me a minute, is that this value right here represents the letter a, the 2 that's in front of the x squared. The value that's in front of the x represents the letter b. And the constant, when the equation is in standard form, represents the letter c in this formula called the quadratic formula. The quadratic formula says if you would just take this value b and take the opposite of it, plus or minus the square root of that value b squared, minus 4 times the value for a, which in our case is a 2, times the c, which is this minus 12, and divide all of that by 2 times a, which in our case is 2, you would be able to solve this equation after having simplified that. So what I tend to do when I solve a quadratic equation by the quadratic formula is I tend to list my values for a, b, and c. Would you please notice that this minus sign, this minus 12, because this is called plus a negative 12, I want to see the negative sign with that constant for c when I plug it in for c in this equation. When I plug it into this equation, I always just say to myself, take the opposite of b. Well, b is 5 here, so I want the opposite of 5, plus or minus the square root of, always please put this value for b in parentheses. Again, b squared, and my b is 5, so I have 5 squared, minus 4 times a, my value for a is a 2, times c, my value for c is a minus 12. All of this is divided by 2 times a, and my value for a is 2. So it looks like I have a 4 in the denominator. And then all I ask you to be careful of, and I like to just do this in my head with a little bit of help of the calculator, 5 squared is 25. I ask people to count the number of minus signs they see in this product right here. This minus 4 is basically a negative 4. You know, think of it as this, plus a negative 4. I have 2 negative signs here. The product of 2 negative numbers is positive. Would you do that? If there's 1 negative sign, put a minus sign here immediately. If there's 2 negative signs, put a plus sign here immediately. If there's 3 negative signs, put a minus sign here immediately. Remember that odd negatives, negative results, even negatives, positive results. I have an even number of negative signs, positive results. Then do the multiplication. 8 times 12 is 96. Please extend this division bar underneath all of it. 2 times 2 is 4. 25 plus 96 is 121, I would say. So I have a negative 5 plus or minus the square root of 121 divided by 4. That will be my solution for x. Finally, that is a negative 5 plus or minus 11 divided by 4. All right, and I should follow through with this and figure it out since I don't have any radicals left. A negative 5 plus 11 is, I'm going to do this over here. A negative 5 plus 11 is 6 over 4. So one of my answers for x is 3/2. And the other answer, a negative 5 minus 11, is a negative 16 divided by 4. And a negative 16 divided by 4 is a minus 4. There's my 2 solutions. If I graphed it, those would be the points where the parabola would cross the x-axis. Please remember, and I've not been mentioning this enough, I just don't have space and or time to produce all these videos and show the checks all the time. You should be taking the solution for x and making sure it fits in the original equation and they get a true statement. Did I mention that you'll need to know the quadratic formula by heart? It's not too tough to memorize, but you will need to memorize this basic statement. Again, not much. I don't know if you can think of a rhythm or a pattern that will go, but it's a negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Got to memorize that. If I use the quadratic formula, the equation's got to be in standard form. This one is not. Make sure that's the case. This one is ready to go if I were completing the square. You know, I've got the constant over there on the right-hand side. But since I'm using the quadratic formula to solve this one, I've got to bring the 5 over to the left and get 0 on the right-hand side. And then I'm inclined to write down that my coefficient in front of my x squared term is a 1, my coefficient in front of my x term is a 2, and my constant here is a negative 5. So now I'll go ahead and plug these values in for a, b's, and c's over here. Again, be very careful, please. First, I want the opposite of b. So that's going to be a negative 2. And then I want to take that b value, which is 2, and square it, and subtract 4 times a, which is 1, times c, which is a negative 5, and divide all of this by 2 times a, which is 1. Let's clean it up. So I have a negative 2 plus or minus the square root of 2 squared is 4. I have 2 minus signs here, 2 negative signs. Remember, that's a negative 4 times 1 times a negative 5. That's a positive 20. All of that divided by 2. Well, underneath the radical, I have an expression that can be simplified, and you need to remember to do that. I have negative 2 plus or minus the square root of 24. Again, needing some room here, I'm going to come over here and say that the square root of 24 is the same thing as the square root of 4 times the square root of 6. Because this is a perfect square, I'm allowed to simplify this expression. So the square root of 24, this is 2 times the square root of 6. I'm going to replace that now. So I have a negative 2 plus or minus 2 times the square root of 6, all divided by 2. And finally, you won't see this as an answer in the back of the book when you go to check it. If this number, or a common factor, goes into each of these terms evenly, I need to reduce this. That denominator belongs to both of those terms. It has to divide into each of those in one way, shape, or form. And this is maybe the best way to show this or to illustrate this. I'm going to remove a factor of 2 out of the numerator. And when I do, I'll need a negative 1 here. And then I'll just have the square root of 6 here. Just distribute this and check it. 2 times the negative 1 is a negative 2, and 2 times the square root of 6 is 2 times the square root of 6. That's all over this denominator of 2, and so I'll remove these factors, and what I have left is a negative 1 plus or minus the square root of 6. That's my simplified answer. I have to be sure to reduce that before I'm done. Okay, let's solve this equation, quadratic equation by the quadratic formula. Again, it's not in standard form, so let's get it that way first. We've been doing the process of what's called transposing by moving the 6x over to the left-hand side and writing it right here as a minus 6x. Would you be sure, please, when you use the quadratic formula to put this in descending order of the exponent, have your x squared term here first, then your x term, then your constant, let it equal 0. And then I'm going to come over here and list that my coefficient of x squared is 1. My coefficient of my x term is a negative 6, and my constant c is a positive 13. And let's plug that in for the a's, b's, and c's in the quadratic formula. So the first thing I need is the opposite of b. Well, the opposite of a negative 6 is a positive 6. So I immediately just go ahead and put down 6 here, because I want the opposite of a negative 6. I don't bother with putting 2 negative signs. Then here, when I substitute in for b a negative 6, especially if I have a tendency to use my calculator needs this negative 6 to be in parentheses so that when I square it, I get a positive 36. Minus 4 times a, which is 1 in this case, and c, which is 13. All of that divided by 2 times a, which is 1. Be careful, this one turns out not unusual. I mean, we've seen this before, but when the number underneath the radical, here I've got a 36, only one minus sign, so I have a minus, and 4 times 13 is 52, all divided by 2. I'm going to end up with a negative number underneath the radical. And I've seen that before, but this is what happens with the quadratic formula when that's the case. I think I've got a negative 16 there, and what I'm going to have now divided by this 2 is, I'm going to put it over here, 6 plus or minus 4i divided by 2. Would you please remember, again, if this number or a common factor that goes into either of these two terms occurs, you need to reduce that. So I'm going to write it by factoring it. I'm going to factor out a 2 out of this numerator, and I'll have a 3 here, plus or minus 2i, and that denominator of 2, and those will cancel out again. So my solution to this problem is 3 plus or minus 2i. So I have these imaginary numbers, actually this complex number involved, as my two solutions for x. Again, please don't forget to do this, and I would like to point out one last thing. If you see that this can be reduced, one other way to do this is to say that 2 goes into here once, 2 goes into here 3 times, and 2 goes into here twice, and you're left with 3 plus or minus 2i right here. You decide how you'd like to simplify it. Either way is perfectly fine. Here's the last quadratic equation that I'm going to share with you. It doesn't quite look like a quadratic equation at the moment, but what I have to remember now is my work back from several chapters ago, actually 2 chapters ago, where I solved rational equations. And that involved getting a common denominator, finding the least common denominator after I factored the denominators. I don't have to in this case, there's nothing that can be factored. So I see that my least common denominator here is 7x times x plus 4. I'm going to jot that down. So we said LCD is 7x times x plus 4. When we solved rational equations like this, we said that we needed to multiply every term by the LCD. I'm going to do that in red to illustrate. So the 1 over x needs to be multiplied by 7x times x plus 4. The 1 over x plus 4, I'm going to put parentheses around that, needs to be multiplied by 7x times x plus 4. And finally, the 1 over 7 on the right side has to be multiplied by 7x times x plus 4. We did all that so that we could clear the denominators. That's why we did this. This would leave 1 in all the denominators. So for example, in this first fraction, the x will be gone, so will the x right here. And I'll have left 7 times x plus 4 times 1, which I don't need to represent. The x plus 4's here cancel out, and I'm up with 7x times 1, or just 7x. And over here, the 7 cancels out here and here, and I'm left with x times x plus 4. And now I can see the quadratic equation starting to take shape, because right here I'm going to have an x squared term. I'm going to clean things up, and I'm going to try to do that fairly quickly. Here I'll have 7x plus 28, and in a minute I'll add that 7x together, so I'll have 14x plus 28 on the left hand side. Over here, x times x is x squared, and x times 4 is 4x. I guess I'll bring that down. Now what I'm going to do is I want to get everything on one side, and I prefer to keep the coefficient in front of my x squared term to be a positive 1. So I'm going to subtract 14x. I'm going to get rid of these two terms, and I'm going to write it down so that I don't make a mistake. I'm going to subtract 28 as well from both sides, and so I have nothing on the left. I have x squared minus 10x minus 28 on the right, and I'm using the quadratic formula to solve this. So my coefficient in front of my x squared term is a 1. My coefficient in front of my x term is a negative 10. My constant c is a negative 28. And I'm not going to go ahead and do that and put that into the quadratic formula. I'm just going to tell you that this turns out to be 10 plus or minus 2 times the square root of 53. There's some simplifying to be done right here. Over 2. And then I did this like this just to remind you that since 2 divides into each of these evenly, I'm going to say 2 goes into here once, it goes into here once, it goes into here 5 times, and my final answer for x for this problem is 5 plus or minus the square root of 53. Now again, I didn't want to take the time to show you the quadratic formula. We've done that enough. I had to put those values in order to solve this equation to find my solutions for x.